Hello everyone, welcome to another lecture series of the wind load. So this is the second lecture where we are going to see that how we can apply the wind load in our ETAP software. In the first lecture of the wind load series, we have already seen that what is the wind load, how the wind load is going to formulate. Then we have seen that what are the factors which are affecting the wind load. In that only we have seen that there was the terrain factor, then was topography factor, and also it was the geometry and the shape factor, and on the basis of the height the wind load was getting affected. So this already we have seen the first lectures. Also in the first lecture we have seen very important thing like what are the different type of the loads actually coming on the wind load, like static loads in the wind load. Then also we have seen the dynamic load in the wind load, and also we have seen that in which type of the structures you require to apply the dynamic loading. So this was a very important thing we have seen, that what type of the structure you require to apply the dynamic loading. Now in this particular lecture series we are going to study that how we can apply the wind load in our ETAPs. In the first lecture of the wind load series I have already explained you that there are two type of the wind load actually it is coming. So if you look at here, that I have already explained you the two type of the wind effect that actually coming in our structure. One was the static one and second it was the dynamic one. So I already explained you that the dynamic one actually you require to apply for the long span cylinder structures, and if you have a taller structure. So for taller structure, long span and cylinder structure you require a dynamic wind load effect, and the rest of it you are required to apply the static wind load effect. So in this part we'll talk about how we can apply the static load in our structure, because as you know that this building which we are doing are not a tall structure or not is a cylinder structure, no there is a long span in this or there in this structure. So generally we are going to perform static wind analysis for this project. So we will do the static wind analysis. Now very important thing before starting that how we can apply the wind load in our VTAPs. One very important things I would like to explain here, that what are the different method from which we can calculate the wind forces. So I will write a topic here, that methods for calculating the wind forces. So what are the method actually are available to calculate the wind forces as per IS-875 part 3. So in the code of IS-875 part 3, what are different methods are applicable for calculating the wind forces. So the first method is of pressure coefficient. So this is the first method, and the second method is of force coefficient. Now I will explain you that when you will use the pressure coefficient method and when you will use the force coefficient method. So when you have to apply the load to the complement of the structure. So if you have to applying the load to the complement of the structure or even you can call it building also. So if you want to apply any load to the complement of the structure or the building, then you have to use the pressure coefficient. So what actually the complement means here, that let's suppose that you want to apply the load to the walls, or if you want to apply the load to the frame, or if you want to apply the load to the roof, then we have to use the pressure coefficient here. So here the load is not applied as a whole. So there is a particular component in the structure, and in that only you are going to apply the load. Now when it comes to the force coefficient, then the load is applied as a whole. So as a whole you require to apply the load in the force coefficient. Now I think you are very clear that in the pressure coefficient the applying of the load is actually done for the complement of the structures. So the component of the structure may be your the walls, or you may be the beams, or you may be the columns, or it may be the roofs. So there you can apply the load particularly, and as a whole if you want to apply, then you have to use the force coefficient method to apply the load as a whole. So I think it is very clear that what type of method you actually going to apply it. Now in this particular building we will use the force coefficient method. So this method we are going to use for applying the load to this structure. In other lecture we will also look at upon the pressure coefficient also, that how we can apply the load through the pressure coefficient. But here in this lecture we are going to apply the load through the force coefficient. It means that as a whole we are going to apply the load in this structure or in the building. Now before starting that how we can apply the wind load through the force coefficient method, one very important note I would like to tell you that whenever you are going to apply the pressure coefficient method in your structure, you have to do the cladding of this structure. So if you look at it, that there is no cladding is done in this framed structure, but whenever you are going to do the pressure coefficient method, you have to first apply the cladding, then only you can proceed the pressure coefficient method. Here in this project we are going to apply the force coefficient method, so I no need to apply the cladding to this structure. So I will just start applying the forces through the diaphragm extent. So first of all you have to define the diaphragm for this project when you are going to apply the wind load by the force coefficient method. So the step 1, so if I write a step 1, it will be first of all apply the diaphragm. So this is the first step you have to perform, which is the applying the diaphragm. So I have already applied the diaphragm. So if you're going to look at it, is it applied or not, you can go to the set display options from here, and you can just click on diaphragm extent options here, and you can apply it. So if you look at here, that we have applied a diaphragm to this building. Now you can hide this diaphragm extent again by going to set display options, and you can just untick this and you can make it apply and close it. Now after that you can go to define options here, then you will go to the load pattern. So this is the second step. So I will write here that step number 2, which is to define wind load pattern. So this is the second step, which is to define the wind load pattern. So for doing that you go to define options, go to the load pattern options here. Now you will define wind load here. So you can just donate W X. So this is the wind applying through the X direction. Make it here as a wind, then choose your code, which is your IS-875 2015. You select this, make it add new load, modify this lateral load. Now you start giving these values as per IS-875 Part-3. So you have to open the code, which is IS-875 Part-3, and this all those values required to give it on the basis of that only. So I will open this code and I will show you how you have to find the wind coefficient values, which is applicable for applying all these values. In the wind coefficient table, the first thing that we have to input is of wind speed. Now this wind speed is given in meter per second. Now wind speed actually depend upon in which city you are designing this project. Let's suppose that you are designing this project in Bangalore. So Bangalore will have a wind speed of 33 meter per second. Let's suppose that you are designing the building in Mumbai. Then Mumbai has a wind speed of 44 meter per second. Now how you will get this wind speed? You will find this wind speed given in IS-875 Part-3. So you will open this code, and on the basis of the cities you will find the wind speed. So I'm going to open this code and I will show you that where you will find this wind speed. So this is the IS-875 part 3 code and it has been revised in 2015. Now you can just move to the wind table. So if you scroll down and come to the page number 54, you will find on the basis of the cities there is a wind speed given here. So if you're designing the project, let's suppose in Nasik, then you have wind speed of 39. If you're designing the project in Pune, then you have wind speed of 39. So like that, on the basis of the cities, you have to define the wind speed. So I'm considering this project is to be done in the Bangalore. So the Bangalore has a wind speed of 33. So if you just see here, Bangalore, which is having a wind speed of 33. Now I will open the tabs here and I will give it here 33. Now next is your terrain categories. About this terrain category, I have already explained in the previous lecture of the wind. That time I told you that there are total 4 terrain categories and we have to select one of them. So how we have to decide that in which terrain category our building will come, I have already explained at that time also. So here also, if you just look at here, that when you just click on this terrain category options here, you will find there are total 4 terrain category that we have to choose here. Now how to select it in which terrain category our building is constructed, it depends upon where you are going to make the structure. Let's suppose that there is a piece of the land I have, and in this piece of the land few structure is already made it here. So the few structure is already are constructed and I need to construct it here. So this will come under terrain category 3 because few structure is already constructed near the surrounding. So if I have a piece of the land where there is no structure is constructed and only the my structure is there to be constructed, then this will come under terrain category 1. So I'm just showing the PPT that how we have to decide it here. So if you just look at here, that there are total 4 terrain categories, 1, 2, 3 and 4, and according to that we have to decide it that where we have to build the structure, what is the terrain condition there. Let's suppose that in our structure where we have to build it, it will come under terrain category 3 because few building is already constructed here. So you have to select terrain category 3. If you are going to make it in the cities where are densely populated cities, if it is there, then at that time it will come terrain category 4. And if there is very few number are constructed building already presented there, then that will come under terrain category 2. And if there is no any structure is constructed or any one structure is constructed nearby it, then it will come under terrain categories 1. So like that we have to decide it. So I'm just in my case, and also for better definition of terrain category, you can open your code, that is IS-875 part 3, and you can just go through the code here. So if you look at the clause number 6.3.21, you will find terrain clause here. Now in this terrain clause only, you will find that total 4 category they have mentioned that. So you can just see that there is total 4 category. So you can just scroll down. This is the category 1. So I will just mark it here. This is the category 1. Then if you just scroll below, you will find all the 4 category here. So this is the category 2, then 3 and 4 also. So this is the clear definition of category they are given, and you can just go through this category definitions. Like when you are going to construct any building, what is your conditions, whether your building is coming in the category 1 or it is coming in the category 2 or it is coming in the category 3 or it is coming under the category 4, that you have to decide it on the basis of definitions here. So let's suppose that if there is a numerous number of the closely spaced obstructions are coming at that time you have to go with the category 4. Like in the cities, densely populated cities are there, so densely constructed building will also will be there at that time, so this will come under category 4, that is structures. So like that you have to decide it. So in my case I will select categories 2 here only, because I'm just assuming that at the surrounding there are few construction are already done, so not that much, very few constructions already done. So I will take it this categories 2 only. Now next is your importance factor. Importance factor is that how important your building is. That let's suppose that you are building any hospital, so definitely for the hospital the importance factor will be more. Let's suppose that if you're building any structure where the occupancy is very large, this is public building is there, public sector building are there, at that time you have to increase the importance factor. Right now I am making some normal building, that is the residential building, so I will keep it this importance factor 1 only. But you can just change if you want going to build the structures like hospitals or very large public assembly building you're going to make it, then at that time you can change to 1.15, like that you can change it. Right now I will keep it this 1 only. Now second is the risk coefficient factor. This also I will explain that what actually it is. Risk coefficient factor generally means that longer the life span of the structure is, longer the risks will be there. To understand this, let's suppose that I have one structure A and I have second structure, that is structure B, and the structure A has a longer lifespan and the structure B is having a less lifespan. Then you only tell me that which will have a more risk to the external forces coming to this structure. You will tell generally the structure A, because it is going to have a longer lifespan as compared to structure B. So we have to consider the risk coefficient factor for the structure A, which is having a longer span life. So the structure like hospital or the structure like monument structures, it is having a more, or we can say a longer lifespan. That's the reason we have to consider a more risk coefficient factor for structure A type of the building. The coefficient depend upon two things. First is your what class of the building you have. So class of building, and second it depend upon what is the wind speed. The class of the building generally means that whether it is industrial building, whether it is a residential building, or it is a public sector building. So like that the class of the structure generally depend, and the wind of the speed you already know that what actually it is. So this risk coefficient factor will depend upon these two of the things. Now in your code only they have given you, so if you just open the code and if you just scroll down, you will find here risk coefficient factor, and here you will find class of a structure. So first class is all general buildings and structure, like that there is a class of the structure, and here only you will find wind speed 33, 39, 44, 47, 50 and 55. And just you can just see that like my building is a general building and structures, and the mean probable design life of the structure is having 50 year, and for this if the wind speed is 33, then I have risk coefficient factor of 1. So let's suppose that I have some important building which is having a longer lifespan. At that time if the wind speed is 33, then risk coefficient factor will be 1.05. Same thing, if the wind speed is more, then risk coefficient factor will be getting increased, that is 1.108. So you just need to see the class of the structure, then you have to see that wind speed, what is the wind speed you are having, and according to that you take the values from here. So this is very simple to find out this risk coefficient factor, and it is denoted by K1. Now I think you are very clear that how you have to calculate the K1 factor, that is risk coefficient factor. Now moving next is your topography factor. So about the topography factor, that is a K3 factor, I have already explained in the previous lecture of the wind load. Now in this lecture I am going to tell you that how you have to calculate, or we can say how we have to take the coefficients here. So you can just see that there is a one written by default coefficients. So how we will take the topographic coefficient, that is K3 factor, while calculating the wind load. That is the things today we are going to study it. So for reference of taking this coefficient value, again I am going to use the code, that is IS-875 Part-3. So again I am going to open this code and I will show the clauses where actually it is written. So if you just open this code and if you just see the clause of 6.3.3.1, you will find that K3 factor actually it is given here, that how you have to take it. So if you read the line here, that the effect of topography shall be significant at site when upwind slope is more than 3 degree. So the effect of topography will come into play when your upwind slope is more than 3 degree, then only it will come to play. Otherwise your K3 factor can be taken as a 1. Now question arises that what will happen if upwind slope is more than 3 degree? Then it is written clearly that the value of K3 is confined in the range of 1 to 1.36 for the slope more than 3 degree. A method of equivalenting the value of K3 for values for more than 1 is given in Annex C. So you have to open the Annex C and have to find the value of K3 when the upwind slope is more than 3 degree. Then only you have to go and do the calculation from the Annex C, and this K3 value will have a range from 1 to 1.36 only. So this coefficient only will come when you're going to calculate with the Annex C, and this Annex C will be only required when the upwind slope, that is theta, is more than 3 degree. Then only you require to calculate it. Otherwise you just take the K3 values 1 only, and this K3 value after calculations also it will come from 1 to 1.3 range only. It is not going to come 3 and 4 like that. So the range will be 1 to 1.36 only. So you can just go with Annex C and see that what actually it is. So you can open the page number 57. So when you open the page number 57, you will find the calculations of the K3. So I'm not going to do the calculations and all. I'm just taking the values of K3 as a 1 only, because my upwind slope is not greater than 3 degree. So I will open the ETABS and I will take the K3 factor as a 1 only. Now next important thing is your exposure height. Now exposure height actually means that in which position your structure is exposed to the wind. Let's suppose that I have any structure here. So this is my structure and this is the superstructure and this is the substructure. And this is the superstructure I have. Now you only tell me that when the wind will come, and let's suppose that this substructure below ground. So which will be the exposed area? Definitely your base or your foundation system is not exposed area. So you will not count exposed area from substructure. You will count from ground floor only, because wind will come or wind will expose to the ground floor area only, not to the substructure or foundation area. So the bottom story from which the ground floor actually you can count it from ground floor, means that your exposed area for the wind will be from ground floor, not from the base, because base is the foundation and the foundation is below the soil. So there is no exposed to the wind for the foundation. So there will be ground floor only which is going to exposed for the wind. So you can take it this as a ground floor, and also you can include the parapet also of, you can include of 1 meter of parapet, 1.2 you can give it. Now this was the wind coefficient and exposed height for the wind load. Now next we have to find, which is also one very important thing, which is the coefficients here. So you can just, you have to give this windward coefficient and leeward coefficient values. So in the code I will tell you that from where you have to calculate these CP values, which is the windward and leeward coefficient values. Now again I'm going to open the code and I will show that from where you have to calculate it. So this is the table number 5 and it is taken from IS-875 part 3 code, and in this table only you will find the leeward values and windward values. So let us look at that how you have to find out. So this is very tricky, that how you have to find the windward and leeward coefficient with this table. So the first thing that you have to find here, that is your building height ratio. So this is the first thing you will find, this is the building height ratio. So when you get the building height ratio, then you have to find building plan ratio, and after finding the building plan ratio, then you have to look at that wind angle, 0 degree or 90 degree. Let's suppose that you have a 0 degree of wind angle. Then on the basis of that you have to find the windward values here. So like that you have to find the windward and leeward values. Now I'm going to explain with some of the example here. So I will take the example of my building, and I will find first of all the building height ratio, then I will calculate the building plan ratio, then I will show you that how you have to take these values. So our first step is to find our building height ratio. So what is your height of your structure? So h, that is coming around 27 meter, and the width of my structure is also 27 meter. So this is taken from our building. So if you taking another example, then you will take your own building height and the width of the structure. Then you have to divide this. So when you divide it, h by w, then it will come 1 only. That is 27 divided by 27, it will come 1. Now you have the building height ratio. Now in this building height ratio, you have to search that in which category my building is falling. So if you just see the first one is your h by w. If it is equal to or lesser than half, then this will come. So 1, is it less than 1 is less than half? No. So if this condition is not fulfilling, then I will cross this and I will move to the next condition. So next condition is 1 by 2 means half. So 1 by 2, and the range is 3 by 2. So if the value is between 1 by 2 to 3 by 2, so 3 by 2 means 1.5. So 0.5 to 1.5. So if the value is between these two of the range, then this category will fall. So generally 1 is between 0.5 to 1.5. So we have to look at this particular table now. So either we will not see this one, we will jump directly to see this one. Now after finding this, we have to look at the building plan ratio now. So I will close this, because why we are taking this, because our building height ratio are falling in this category. Now next work is to find out plan ratio. So plan ratio, how you have to look at here, that plan ratio, it is very easy to find out. Like if your structure or something which is in the form of rectangular, then this will come, and if your structure is something like a square, then this will come. Okay, so you can just directly go and see the shape of the structure. So you can just see that in my case the shape of the structure is completely like rectangular. So you can do the calculations also, better to do calculations, but I'm ignoring the calculation because definitely this category will fall here. So definitely this category will fall of rectangular. So I'm directly jumping to this, I'm not doing the calculation. If you do the calculations also, it will come this only, because you can look at the shape how actually it is. My building is square, no, so this will not come, this will only come. So I'm directly taking these options here. Now after taking this option, and I recommend you to do the calculations also, the calculation is here, you can do the calculation and then you commit. But I'm just jumping to this step because I know that my building is rectangular. After finding this particular plan ratio, our next job is to find the angle. Now angle is very simple to understand. We are applying the forces in wind x direction. So the x direction I will take it 0 degree, and y direction I will take it 90 degree. It's very simple to understand. If you're applying the forces in the x direction, then x I will take it 0 degree, and y I will take it 90 degree. Now you understand this. Now come and apply the same thing concept here only. So if you look at here, that they written theta here, and also they are given 0 degree and 90 degree, and also they have mentioned a b c d. So a b c d. So when any forces is applied in this direction, so this will be the windward direction, right? So this will be windward direction, and just opposite of this will be leeward direction. This I have already explained in the previous video. So this will be the leeward directions. Now you only tell me that if the angle of degree is in the 0, so angle of degree is 0, then how much I will get the a value? So a value I will get it, you just see here, a b c d. So a is 0.7. Now just opposite of b will be leeward direction, and this value will be in the negative form, and you can see here that the b values is coming minus 0.3. And same thing is applicable when you're going to apply the wind load in the 90 degree. So if you're going to take 90 degree and the forces is applied in this direction, this is the windward direction, then d value will become positive. So if you just see here, the d value actually it is coming if same thing is applied in 90 degree. So if the wind y I need to apply, so this is the direction of the force will be there, and this c will become windward side, so and d will become leeward side. So in the direction of the force it will become windward, and just opposite of direction of the force will become leeward side. So this will become leeward side d, and if I need to find the c values, so I require to see the angle 90 degree, and this c 0.7 and d will come 0.1. So like that you have to look at the values. So I think you have understood carefully that how we have to find the coefficient values. So here I will take plus 0.7 for windward and minus 0.3 for leeward. But when you are going to input these values of minus 3 in ETABS, it will not take it negative values. It will cancel the negative values. You by default negative values is already taken here. So you need to input only 0.3. So you can just open ETABS here, and if you just close this, and if you just see this windward coefficient here, so instead of 0.8 you give it 0.7, and for leeward you give it 0.3. Don't give it minus, it will give you error. Okay, values cannot be 0 or negative, so give it 0.3 only, because by default only take it negative, don't need to mention here. Now this wind direction exposed width you give it here 0 degree, and in the case of y direction I will give it 90 degree. So you give it okay and give it okay. Now same thing you have to define for y direction also. So wy will be for y direction, everything will remain same. I need to modify this lateral loaded, and instead of at the wind speed I have to take it 33, and terrain criteria it was 2 only, impedance factor was 1, this coefficient factor was also 1, and topography was also 1, and this bottom story will become here ground floor, parapet will 1.2. the changes I require to give it in the windward and leeward coefficients. So if you just open the code here, I told you that to take it 0.7 and 0.1. So you can just take it here 0.7, and this will become 0.1. Don't give negative sign here, you give it 90 degree here. Instead of giving 0 degree you have to give it 90 degree. In case of wind X you give it 0 degree, and in case of Y you give it 90 degree. After that give it OK and OK and OK. Finally your wind load is applied to this structure. Now you can run the analysis. Now you can look at the result, like what is the deflections and all. So you can go to the source deflection shape here. You can just take the WX and you can just draw the contours also in the X direction. You can just take it. And you can see that how actually this structure is deflected in the X direction. And if you want to look at in the Y direction, you can just select WY contour. You can take it for Y direction, apply it. So this structure is deflected due to the wind in the Y direction. Now you can just close this. Applying the wind load is over. In the next lecture we will look at it, how we can look at the result, and after that we will see that how we can have a load combination for the wind load for designing the frames. So this we will see in the upcoming lectures. Thank you for watching.